What's up, Five Keys? Module 5, Lesson 1. We're going to dive right in. A lot of it is a review from Module 4 with some different terminology. So let's just take a look. I'm not going to really hit this too hard on this video. We may come back and do another video for this one later. But if you're working on Module 5 right now, I want to be able to give you at least some insight onto what's going on with some of this language stuff, because a lot of it's just that the language is a little tricky. All right, so I am looking off to my right where my assignment is. So you should be sharing screen right now and being able to see Module 5, Lesson 1, rate of change. This is the assignment. So you'll be able to find rates of change from tables and find slope. I got a hint for you. Rate of change and slope are exactly the same thing. That makes it easy, right? A rate of change is a rate that describes how one quantity changes in relation to another quantity. If X is the independent variable and Y is the dependent variable, then rate of change equals change in Y divided by change in X. Rates of change can be positive or negative. All right, so what is that all about? A way in which we generally see this, even though we don't think about it, is the speed in a car. So if I'm going to graph me traveling somewhere, let's say I'm going 100 miles, right? And this y-axis is distance. This is the dependent variable. And my x-axis is time. Let's say this is 2 hours, right? And this is 0. Well, my rate of change then is my change in y is the 100 miles minus 0 where I started, and my change in x is my 2 hours minus 0 where I started. I have 100 minus 0 is 100, 2 minus 0 is 2, which gives me 50. My rate of change is 50. Now, what gets interesting is when we look at units, this could be miles, this could be hours, because we just divided, so our units are now divided. So I have miles per hour. We're used to seeing this as miles per hour, right? We know this from the car. We drove for 2 hours, we went 100 miles, we had to do 50 miles each hour on average. We ended up at going 50 miles per hour. So the graph isn't graphing speed, it's graphing distance and time. But when we relate it to rate of change, all of a sudden we get speed, we get velocity, miles per hour. Hence, that is also the slope of the line. Rate of change and the slope are the same thing. Change in y divided by change in x. Okay, let's clear that drawing. I hope they don't say something different. Let's see. Slope is the steepness of the line, also commonly known as rise over run or rise divided by run. Okay, what does that mean, rise over run? If I have a line here, my change in y yeah, let me do something a little bit different. Clear all the drawings. Okay, so here's my axes. Here's my line. I'm gonna go crazy with colors today. This is my change in y. If I were to subtract this distance from the total distance, I would just get this. This is my change in y. It's also my rise. Is how much that line went up. It's how much The 1 point, the last point went up from the first point, right? It's the change in y. It's the rise that's on the top part of the equation or the expression, and the bottom part is how far left to right it went. That's my run. All right, so the rise, how much it went up, divided by the run, how much it went across, will give me my level of steepness. So if I'm on a really steep hill, if I'm hiking and it's like this, look how much bigger the rise is than the run. This number is really high. This number is really low. So the total number is going to be pretty high. If I'm on a very narrow slope, or very small slope, it's much easier to hike that, right? Well, the rise is a small number, the top number is small, and the run is a big number. So I'm going to get a number that's really close to 0. Okay. Really quick, I'm just going to lay some groundwork for what a negative slope looks like. If I'm hiking from left to right and I'm going downhill, all of a sudden, that slope is not rising, it's falling. So this number is going to become negative. And my slope, my level of steepness is also going to be negative. So if I'm on that hill, I'm not hiking up it, I'm rolling down it, hopefully walking down it. But sometimes if it's too steep, you may roll. One moment, please, while I figure out what's going on with my computer. Where's my thing? Let's stop share for a second. Share screen. Okay, I'm back. Okay, so let's see where we are here. That was STOPE, introduction. In Unit 4, you examined functions that were linear and nonlinear by looking at their table patterns and graphs. Remember, a linear function is going to be a straight line. And the rate of change, what we just discussed, the slope, will always be constant. It's not going to vary. And they give us some charts here. I'm just scrolling through because I don't want this video to go on too long. I want to get to the quiz. Yeah, constant, we discussed that. Okay, example 1, marching band. The table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? What does the rate of change represent? So in this example, distance depends on time. So the rate of change can be written as change in distance, that would be my y-axis, change in time, that would be my x-axis, or my independent variable, change in time, and my dependent variable, change in distance. All right, so if we look, the change in time is always the same, 1, 1, 1. That itself doesn't mean that the slope or the rate of change is going to be constant for the whole equation. It just means that for that one variable, the data they're giving us in the table is constant, and it'll make the math a little bit easier. The rate of not the rate of change, the change in the dependent variable, well, 260 to 520 is 260. 520 to 780 is 260. And 780 to 1040 is also 260. So the rate of change is 260 divided by 1, 260. 260 divided by 1, 260. 260 divided by 1, 260. So the rate of change for the whole equation is 260. And it's constant, at least in the data that they've given us. So is the rate of change in distance with respect to time constant? It is. It's always 260. What does the rate of change represent? I don't know. I don't know what the answer that they want. Just being really honest. Let's see what they give us. Okay, so they're saying it's the speed of the band. They are going 260 feet per every minute. And we discussed that in our example about driving, where we went 50 miles an hour over 2 hours. You try. Looking at the table above, I'm assuming they're talking about the marching band. Do you get the same rate of change if you use non-consecutive rows of the table? What? All right, so first of all, what they mean by non-consecutive rows, what they would have meant if they had said consecutive rows is the row right after it, right? So this row, the time 2 is consecutive with 1, 3, 4. So by non-consecutive, they mean what would happen if we skip down a row? So if I take 1 and 3, we can use that. What's the change between 1 and 3? Well, it's 2. What's the change between 260 and 780? Well, it's 520. All of a sudden, our numbers look a little different. But remember, we weren't just taking the 260. We were taking the 260 divided by the 1 over here. So now we're taking the 520 divided by the 2. The rate of change for the dependent variable, our rise, our y, divided by our rate of change for our independent variable, our x. So we have 520 divided by 2. Yep, it equals 260. So we're still good. It still makes sense. Our slope is still constant. Our rate of change is still constant. Remember, those things essentially mean the same thing. So I would say something to the effect of yes, because the change in the dependence variable is, what did I say, 520? But the change in the independent variable is 2. So the rate of change is still 260. That works, right? Okay. Another way to name the rate of change is slope. Slope is a ratio or the fraction of the change in y over the change in x. The little triangle is something that we is named delta. Oh, it's going to explain down here. It's the Greek symbol for delta. It's like the Greek letter D. I don't know why that means change, but it does. Okay. Rise, run, we discussed that. Find the slope of each line. Okay, so now we're going to decontextualize this and look at it with pure mathematics. We're going to find the slope of each line. Remember, slope and rate of change, what we've been discussing, are exactly the same thing. So looking at the 2 points, -2 and 1, let me pull up my handy dandy pointer thingy so I could do this for you. Looking at the 2 points, -2 and 1, so there's my -2 and 1 right there. And 1, 1, there's my 1, 1 right there. The vertical change is from -1 to +1. By vertical, they mean the up and down, the y, right? So if you notice, they went 1, 2, and now we're in line with 1. So the vertical change, that's my change in y right here, is 2. I just went up 2. And they're doing math a little bit differently, but it is all going to come out in the wash. The horizontal change is from -2 to +1 or right to 3. So they went 1, 2, 3. And the horizontal change, or the change in the independent variable, the x, is 3. And the slope of this line is level of steepness is 2/3 positive. And I know it's positive just by looking at the graph, because if I had to walk from 0 to the right or from left to right, I would be walking uphill. And whenever I'm walking uphill, it's going to be a positive slope. So let's look at the next one here. It's downhill. So I automatically know without doing any mathematics that my slope is going to be negative because it's going downhill. Looking at the 2 points, -3 and 2. That's my first point. And my second point is 2 and -2. So if I'm going to look at the second number, because that's my Y number, that's my vertical number, that's my up and down. So how do I have to get from 2 to -2? I'm going to go down 4. 1, 2, 3, 4. Because it's down 4, it's essentially a negative number, depending on how I want to do that math. But here's my 4. And notice when you calculate change arithmetically, procedurally, they're using subtraction. They took this number and they subtracted this number. But a 2 minus a -2, remember, minus means to add the opposite of. So this became pop up, it became 2 plus 2. And they ended up with 4. Okay, so now my run. They went right 5. 1, 2, 3, 4, 5. Or -3. They took this number first and they subtracted a +2, which is the same as adding a -2. Add the opposite of, and they came up with 5. -5. So they came up with +4, -5, the ending, which would give us a negative number, -4/5. But we already knew it was going to be negative because we saw that the slope was going down. If we had to walk from left to right, we would be tumbling down the hill. Okay, let's clear that. Bloop. Let's see what else I got. You try. All right, we'll do these together. So they changed this up a little bit. This should have a Y. I don't know why it doesn't. So this is the same thing as this little formula here that they gave you. It's the same thing as saying change in Y divided by change in X. They're just showing you here that it's subtraction, and they're giving you Y. This should be subscript, but it's not. Y sub 2 minus Y sub 1. This 2 and this 1, that number doesn't have value. That's just an indicator of this is the second point and this is the first point. This is the X from the second point. This is the X from the first point. And it actually doesn't matter. And which you choose, just as long as you're choosing the same point. And I'll show you what I mean. So I'm going to identify the 2 coordinates. I'm going to name this one X sub 1, okay? I'm sorry, 0.1. I'm just going to call it 0.1. I'm going to call this one 0.2. So my coordinates for 0.1 are my X is -3. That's this number here. And my Y is +1. That's this number here. For my second point, then you can put that here on when you're actually doing this assignment. My second point here's my X value is 2. My Y value is 3. Okay, now I'm going to calculate the change. So I'm going to start with Y, change in Y. So here's the Y values right here, 3 and 1. So I'm going to take Y sub 2, that's this number here, 3, minus Y sub 1, that's that number here, 1. And I'm going to divide it by X sub 2, that's this number here, 2, minus X sub 1, that's this number here, -3. And what does that leave me with? Well, 3 minus 1 is 2. And 2 minus a negative 3 is a positive 5. So my slope is 2/5, okay? Now, it doesn't matter which point you label the first point and which point you label the second point, as long as the coordinates are lined up vertically. So if you see how here's the 2 and here's the 3, notice here's the 2 and the 3 is right on top of it. Here's my negative 3 and here's my 1. Here's my negative 3 and here's my 1 right on top of it, okay? As long as it's consistent, you can label them, you can label whatever point you want, P sub 2 and P sub 1. And I'll show you how that math works out. So if I were to have labeled this one 2 and this one 1, I would have 1 minus 3 here, and I would have negative 3 minus 2 here, and that would give me a negative 2 divided by a negative 5. But a negative divided by a negative is a positive, so I don't need those negatives. So I'm not even going to write them in anymore. I'm just going to say 2 divided by 5. And if you notice, that's exactly what I got when I had the coordinates the other way around. So it doesn't matter which one you label P sub 1 and P sub 2, as long as the coordinates are directly on top of each other, like I pointed out a moment ago. Okay. Scooch, 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 scooch. Oh, wait, should we do B? Yeah, we should probably do B. All right. So I'm going to call this one my first point, and I'll call this one my second point. But again, it doesn't even matter. So my X coordinate there is negative 3. My Y coordinate here is, that is the silliest looking 3. My X is negative 3. My Y is 2. On this next point here, my X is positive 3. My Y is 0. And now I'm going to do the math, okay? I'm going to say, I'm going to take my Y's, 2 minus 0. I use that top point as my X sub, as my Y sub 2. So I need to use the exact same point, the X coordinate for that first point, and put it underneath. Negative 3 minus 3. This is 2 minus 6. And if we remember our fraction math, that can reduce down to 1/3. Also negative. And the negative makes sense because look, it's going downhill. I also want to point out that the rise over the run should be 1 to 3. So if I draw 1, if I go over 3, I should run into the line again. 1, 2, 3. Oh, I do. If I draw 1, I should run into the line again. 1, 2, 3. I do. Right. So my rate of change is relating the vertical drop or rise to the horizontal run. Right. And that's my slope. That's my level of steepness. Okay. Boom. Now, I calculate the slope of a line passing through the point -1, 0, and 3, -2. This is the exact same thing, only they haven't given you a graph. So I'm going to steal Mathway here for a second, and 3, -2, -1, 0. I'm going to type those points in. You know what? I wonder if I could just copy and paste them. Let's see. I can. Okay, so I just typed it in there. Let's see what it says. Find the slope. What? The slope is -2. Tap to see the graph. Oh my gosh. That's simple. Okay. So technology can do a lot of this work for us, but it's important that you also understand what's going on, right? So use the calculator to support your learning, not to replace your learning, if you would. You were adults. I trust that you guys, y'all could make that distinction. Okay. Find the slope of the line passing through the points 1, 3, and 4, 1. Okay, I'm going to do this one for you the old-fashioned way. I'm going to take my y values. I'm going to use this as my my second point, and I'm going to go 3 minus 1. I'm going to take my x values and line up the coordinates that belong to each other. So the 1's paired with the 3. 1 minus 4. I'm going to divide those answers. 3 minus 1 is 2. 1 minus 4 is -3. And my answer is -2/3. Okay, find the slope of lines A and B, a horizontal line. So if you notice, in the case of a horizontal line, my x values, these first numbers are different. They're different, but my y values are the same. And that's going to be in every horizontal line ever. So 2 minus 2, I'm subtracting my y's, I'm finding the change in y. -3 minus 2, I just calculated my change in my x's, right? They're different. 0 over -5. Whenever you see a horizontal line, this is equal to 0. Whenever you see a horizontal line, a flat line, your slope is 0. Your rate of change is 0. You do have a rate of change, but it's 0. It has a value, but that value is 0. I'm making a point of making that distinction, and you'll figure out why in a second. But if I'm walking on a hill, I can walk. There's stuff that I can walk on. It's just flat. It's not actually a hill. It's just flat ground. 0. Okay. That's different than the thing we're about to look at. Okay. Oh, I see. That's good to know. A vertical line is straight up and down. So if you notice, the x has value, right? Because the y has value because they're different. 1 and -2, but the x's are the same, -2 and -2. So I just subtracted a number from itself. Whenever I subtract a number from itself, I get 0. Whenever you're dividing by 0, your answer is undefined. It doesn't have a value of 0. It doesn't have value at all. It doesn't exist. It's undefined. So if I'm on a hill, I'm walking along, I'm walking along, and then all of a sudden, boom, that doesn't have slope. I'm not on a hill anymore. I'm free falling. I'm in trouble, right? It's undefined. So whenever the x's are the same, that slope is undefined. Whenever the y's are the same, that slope is 0. Y's are the same, 0 slope, horizontal line. X's are the same, vertical, undefined. Okay. Division by 0 is always undefined. It's if you plug that into a calculator, it'll tell you no, it won't even do it for you. It'll say that there's a syntax error, or it'll literally say undefined. Okay, here we go. X's are the same, Y's are different. Vertical line, undefined. Y's are the same, X's are different. Horizontal line, 0. To summarize, whoa, that was so much math. All right, we're gonna look at the quiz and then be done. So we know the rule with the quiz. Stop the video, do the quiz on your own, and then come back. All right, so you're stopping the video. Whoa, you're doing the quiz, and the quiz is over, and now we're back. Okay. Here we go. Are we back? We're back. So just in case you haven't done this yet, although I think everyone has, you do the quiz on a separate sheet of paper and then take a picture of it, or you can do it on a Google Doc and then do it that way. The table shows the distance a cyclist rides her bicycle over time. All right, so we see we're getting distance in feet and time in minutes. Is the rate of change in distance with respect to time constant? Explain. A lot of vocabulary just there to confuse you. All they mean is the slope the same, all right? So we're always changing by 1 here, 1, 2, 3, 4. So as long as we're making consistent jumps with our distance here, we're good. So we start at 1,120 feet. We go to 2,240 feet. That's a change of 1,120. It just doubled. If I add this to that, I get 0.633. Great. So that's also, this is also a change of 1,120. If I add this to this, I get 2,240. If I add this to this, I get 3,360. If I add 1,120 to 3,360, I do get 4,480. So yes, I'm writing here yes. Let me write it in text so you can see. And then I'm going to offer an explanation. Yes, because in each minute she travels 1,120 feet consistently. Move over. Cool. What does the rate of change represent? Her speed in feet per minute. Right? That's how fast she's going. In every minute, she travels 1,120 feet. When we're not used to talking about velocity or speed in terms of feet and minutes. We're usually talking about it in terms of miles per hour because we drive, but that's what it is. Okay, I'm going to clear my drawings. And we are going to go on to numero dos. What is the slope of the line shown below? Okay, this one's a little tricky because it doesn't give us clear points. It doesn't like give us dots. So I'm just going to pick a couple points where I feel like this graph is intersecting a coordinate at an actual point. So this is a good one here. This is a good one here, but I'm pretty sure it's also crossing here. So I'm going to use this one and this one. Okay. So this point I'm going to call the X coordinate is -5 and the Y coordinate is +5. All right. Here, that to me, the X is 0 and the Y is 1. That's this point right here. So let's see what I get. If I do My change in y is going to be up top. I'm going to take that first point and list it first. And my change in x is on the bottom. Five minus 1 is 4. -5 minus 0 is -5. So this is my slope, -4/5. So that means that for every 4 I go down, I should go 5 over, right? So I can do a quick test. And the first thing I'm kind of interested in noting though, before I do that test, is the sign, and it's negative. So it should be going downhill from left to right. And indeed it is. Left to right, downhill. Okay. But let's look at the slope and make sure I'm doing this right. So if I go over 4 and down 5, I should get there, right? 1, 2, 3, 4, and down 5. 1, 2, 3. Whoops, I'm sorry. 4 is the rise, -5 is the run. So I should go down 4, right 5, and I should get there. 1, 2, 3, 4. 1, 2, 3, 4, 5. Something's not right. Teacher made a mistake. Let me see again. 1, 2, 3, 4. 1, 2, 3, 4, 5. What? Oh, look at that. Okay, teacher error. This is a good error to make. I don't know if you saw it before me. Maybe you did, maybe you didn't. I went wrong because this is 4, this is 5, this is 6. So this coordinate's wrong. This is how math works. We check ourselves. This is a great, completely unintentional, but a good learning opportunity for everyone. So this point really should be -6 and 5. And this point, I think I got right. Yeah, 0 and 1. So 5 minus 1 is still 4. -6 minus 0, though, is -6. And this actually can reduce to -2/3. And now let's do the test. So we should go down 2 and over 3 and hit it. 1, 2, 1, 2, 3. Yep, there we go. 1, 2, 1, 2, 3. There we go. 1, 2, 1, 2, 3. Yep. 1, 2, 1, 2, 3. Okay, there is our answer, -2/3. Let's clear that and move on. I think that might be it, or maybe there's one more. Yay, we're done. Okay, so if you got some of those quiz problems are wrong and you still are unclear, please email me or whoever your teacher is. If I'm not your teacher, I'm sorry, you have to bear with me on these videos. I'm sure your teacher is much better than me. Okay, I am signing off. Thank you. Bye. Nope, I'm not just yet. I'm gonna stop the share and then I'm gonna